Hello and welcome to PTI's educational webinar mini-series. Today we're going to be talking about test method migration. And when we speak about method migration, we're speaking about moving from one test method to another test method. So you ask yourself, why would we shift a technology that we currently have in place? Why would we change our current method? And the fact is very simple. It may no longer be capable. So a test method that you have validated decades ago, a water bath or a dye leak test, may no longer be capable for a new package format that you have, or maybe it's an oxygen sensitive product and that water bath is just not achieving the sensitivities that you need. So that's certainly a very critical reason why you might shift to a new method. There's other reasons as well, such as the running cost of a destructive method. Some of those methods seem cheap up front, but a water bath long term is very costly. The practicality of a method, such as the dye leak test method, it's just not clean. It's a messy test, and you can't have that dye near the production line. A final reason why you might shift to a newer technology is data integrity. Many of the earlier technologies produce attribute test data, and that data itself just is recorded manually. It doesn't have an automated means to record that data. Some of the newer technologies have that ability to automatically record the data and put it into a data historian. So that's very important. When we're looking at deploying a new test method, we have to ask ourselves, what are the factors that we care about the most? Two ways that we often categorize or describe a current technology is the sensitivity that it has and the speed at which it's inspecting the product. What's really important is that you should not compromise accuracy for speed. Accuracy should always be the priority, and if that means slowing down the inspection to a degree, that's what it takes. Accuracy is one of the most paramount factors when selecting a new test method. When we're transferring a test method, we have to step back and ask many questions of the current test method. It's not just a leak test, it's doing a lot of other things. So really step back and ask yourselves deeper questions about the current method. What's the capability of that method, the reliability, and the practicality? We have to be as good or better than that current method if we are replacing it with something new. So you want to be as good or better than. Being as capable, meaning sensitivity, or as reliable, those are the two most important things. If a method is not as practical, it will weigh on the operational deployment of that test method, but it's certainly not a critical aspect to it being successful. But you certainly want it to be as practical as a prior method. So it's not just data that we're producing a lot of other understandings around the container format. And so understanding what that test data is, what's actually being produced in a leak test, that's very important. You're not just producing a number. There may be some softer information produced in that test method. So understand what that is. Understand how different package formats react to a test method and the force that it's being exerted to. So most test methods do have some sort of energy or force that's being applied to the container. Understanding that will allow us to apply a similar force so that the container is experiencing a very similar test. So these are some of the factors that you have to ask yourself when stepping back and looking at your current test method. So as an example, the oxygen headspace test, it's a 6-day dwell test. So you take a package, place it on a shelf for 6 days, and after 6 days, it has to meet that 3% oxygen pass-fail limit. If the oxygen is higher than that, then clearly there's a leak or there's an issue and oxygen has gotten into the package. So this test is not just a leak test, it's actually testing if the modified atmosphere packaging system is actually functioning. So it's not just a leak test. That's really important to understand. It's only picking up defects greater than 100 microns, but it's an oxygen critical product and an oxygen critical leak test. So the fact that it can only detect leaks down to 100 microns in this 6-day dwell period just means it's not really a leak test because it's not achieving the leak test requirements demanded by this oxygen critical product. So really what this O2 headspace analysis test is is just to see, is that map system functioning? So stepping back and understanding that test method is very important. You should also note that that method, if you find a defect after dwell for 6 days, you could have $800,000 worth of product sitting there on hold after you get a false result or a positive result. So the bubble leak test, this is another test that we find often in the industry. You can use it for pouches or for cans. It operates very differently for pouches and cans, but it is a well-known test and widely used. Now it has variable inputs very simply because when you pull vacuum on a pouch, it expands, and after it reaches maximum expansion, only then are you making a leak test out of the method. So it has these variable inputs, something that you have to really understand. If you're trying to deploy a test method, having control of those inputs is very important. The results of the test method are attribute. Does an operator see bubbles or not? And in fact, they are subjective. So the reliability and the quality of that data is not as good. That's very important to understand. So if we're looking to replace a water bath test, you have to really capture all of those things that it is doing. It's also putting the package under some stress. So that is creating almost like an altitude leak test. And that's something we can mimic with another vacuum-based test. But the water bath is not able to go to deeper vacuums on a peelable seal. That's one of its limitations. So if you have a peelable cup or pouch, the sensitivity of the water bath is limited by the peelable nature of those seals. So we want to mimic a water bath, but before we do that, just know this: the water bath is very costly. So in a single production line with very conservative figures put into this calculation, a water bath may destroy about $175,000 worth of product annually in its use. So it may be a cheap test method up front, but long term it's very costly. So it's a reason why we might consider shifting from a water bath to something that's a little bit more cost effective. So when looking at the water bath, we have to really ask ourselves all about that method and what's it doing to the package? What is it exerting the package to? We also see that it's a vacuum-based method. So on a flexible package, it is applying some sort of stress to the package walls. And that's perhaps a valuable test that you may want to consider. So we have to meet the sensitivity, the practicality, and the reliability of that water bath. Matching the cost is also a very important consideration. Long term, a vacuum decay method will beat out the water bath test on cost. So the vacuum decay method, very simply put, we're pulling vacuum on a package in an enclosed test chamber and monitoring that vacuum level. And as you pull vacuum, we're also putting some stress on those package formats, similar to the water bath. If you want to apply stress on a package format, we can design a test chamber to fit the package and allow for that expansion and put that stress on the package to match a water bath and to simulate an altitude type test as well. For flexible packaging, if it's peelable, certainly those tests are not really an option. So you would want to operate using a flexible test chamber, and a flexible test chamber conforms to the package shape and size under vacuum, preventing any undue stress to that package. And that's really a valuable thing when it gets to being a non-destructive method. After performing that test method, we can deploy the product to the market. So when we're comparing two different test methods, we have to ask ourselves, how do we really know when one method is better than another? It becomes very challenging if you have an attribute test method and you want to replace it with a quantitative test method. Attribute data is certainly not that valuable when it gets to statistical tools, and it doesn't allow us to really analyze the performance of that test in a way that a quantitative test method would. But if you did have a quantitative test method, using signal-noise ratio is a very valuable tool. And signal-noise ratio is simply comparing the population of good samples here and the mean that it has, and how different that population of good samples and the mean is from these defect samples or this signal. And this is a very simple calculation. So the signal-noise ratio is simply looking at the difference between a defect result and the mean good results, and then comparing that with the standard deviation of these good results. A signal-noise ratio tells us how effective a test method is at detecting those defects. And if you have a signal-noise ratio for a method that is higher than another method, a higher signal-noise ratio is always preferred. That shows a better capability. So also when we're looking at choosing a new test method, we have to ask ourselves about site-to-site transfer. So you've selected a new method in Mexico City, now you have to transfer it to Europe. And if that's the case, you have to ask yourself, what are those inputs? And what is needed at the site where the test method is going to be transferred to? And if you have a quantitative test method, a method that has measurable inputs, that has a calibration capability, that is very valuable in starting that process for site-to-site transfer. But you also have to ask yourself, what are the other considerations? So if you go to Mexico City, it is at a higher elevation, it is at a lower pressure, and given that, you have to ask yourself, what does that do to the package format itself at the current site? What might that do to the inputs to a test method at the site where the product is being transferred to? So are you using a true absolute pressure measurement or a gauge pressure measurement? So these are considerations that you have to ask yourself when you're moving a method from one site to another. So in summary, it's not just a leak test. We have to look at the bigger picture and understand all the factors that this test is challenging the package to. There are multiple objectives of every method. Understanding that allows us to mimic that method with something new. So if you start with that deeper questioning of your package and the process and the test method that's in place, you can really tease out all that information that's needed to then choose the right method going forward. And we can validate against the input factors that you have, as well as the output results that you wish to achieve. So with that, I thank you for joining us today for this educational webinar mini-series and look forward to many more. Thank you.